Hello, everyone. I hope you're all doing well. We are now going to be talking about techniques for finding derivatives. So instead of using the definition, the limit as h approaches 0 of f at x plus h minus f at x over h, instead of using that definition, we're going to go through the different rules that can be proven by definition in order to calculate derivatives in a easier manner. So the first one we're going to start with is the constant rule. So let's say that we have a function that's constant, so maybe it's equal to pi or 2, basically some number. There's no variables. If that's the case, then our derivative is going to be equal to 0. There's no rate of change. So let's say, for instance, we had f of x is equal to 10. Well, if we take the derivative, because 10 is a constant, we have 0. If we were to have pi, for example, again, this is just a constant, a number with infinitely many decimal places, so this is also going to be equal to 0. Next, we're going to talk about the power rule. So this is for polynomials, but the exponent, could also be a fraction or a negative number. So positive, fraction, or negative number. So if we have something like this, and we want to take the derivative, we can write f prime of x. If you want, you could also write df dx, so the derivative of f with respect to x. This is equal to, what we do is we bring down the exponent, and it'll multiply by whatever c is, so c would be some number, and then we subtract 1 off the exponent. All right, this is called the power rule. And another thing to keep in mind is that, say we have functions that are added or subtracted together. In this situation, when you take the derivative, assuming the derivative of these individual functions g and h exist, it means that we can take the derivative of these separately. Okay, so the derivative distributes to each term when we're adding or subtracting. So with this in mind, let's look at a few other examples. So say we now have the function 10 times x. You won't have to go through all this detail every time, but for now, I will write it out. So we have our 10 here. Really, there's a 1 in our exponent, so we would bring that down. So we would have 10 times 1, x to the 1 minus 1. X to the 0 is just 1, so basically we have 10. Whenever you just have an x, when you take the derivative, it just cancels out the x and you just have the constant. Let's say we now have pi x squared. For this situation, we're going to have, for our coefficient out front, we're going to have pi times 2, and then we'll have x, 2, we subtract 1 from the exponent. So in other words, we have 2 pi times x. For this one here, 3 to the square root of x, remember, the square root just means x to the power of 1/2. So if we wanted to take h prime of x in this case, we would have 3 times, we still bring down the exponent, x, 1/2 minus 1. 1/2 minus 1, we do a common denominator, so this would become 2 over 2. So 1/2 minus 2 over 2, this is negative 1/2. Okay, so we would have 3 over 2 out front here, and then x to the minus 1/2. If I asked you to have positive exponents, what you could do is write it as 3 over 2, 1 over x to the 1/2, or if you wanted to put it back as a root, you could write 1 over the square root of x. Now let's look at this one. So this is a whole bunch of terms added up together. This is a type of polynomial. Notice this time our function is just called y. So to take the derivative in terms of notation, we would say dy dx, so differentiating with y with respect to x. And now let's do each term since we can distribute the derivative. So we would have 3 times 7, x to the 7 minus 1. And then I would have minus 2, bring down the exponent, x to the exponent minus 1, plus 1/2, bring down the exponent, x to the 2 minus 1, And then we can just write this one as -1. And then this would be +0 because it's a constant. So what do we have? We have 21 x to the power of 6 minus 10 x to the power of 4. 2.5, the 2's cancel, so we have just plus x. Now again, if you wanted to go straight to this term, that's fine, but I'm just showing you all the details to make sure that you can see where it's coming from. All right, let's now do this one, p of t. So before I take the derivative, I'm just going to rewrite this so I can more easily do my power rule. So remember, the square root is the same as t to the power of 1/2. And now this one, 2 over t, this is equivalent to saying +2 to the t minus 1. And now we can do our power rule as we normally would. So we're going to distribute the derivative to each term. The first term would be 12, bring down the exponent, and then subtract 1 from the exponent. Then we have -2, bring down the exponent, subtract 1 from the exponent. +2, bring down the exponent, subtract 1 from the exponent. So this is going to give us 12 times 3 is 36. T squared minus the 2.5 would cancel, and we would get t to the negative 1/2. And then I have minus 2, t to the -2. Now again, if I asked you to put this into positive exponents only, we would have to write it like 36t squared minus 1 over t to the 1/2, or again, if you wanted to, you could do the square root of t, and then minus 2 over t squared. Now, this one, for those of you who know some of the other rules, such as the quotient rule, you could do this with the quotient rule, but notice that we can distribute this 1 over x to each term. So we could rewrite this as x cubed over x plus 3, and I'll write this as x to the 1/2 over x. Okay, so this one just means x cubed minus 1, so this is just x squared, plus 3, x 1/2 minus 1, so this is -1/2. And now it's in a form where I can take the power rule directly. Okay, so what do we have here? Bring down the 2 exponent, x to the power of 2 minus 1, plus 3, bring down the exponent, -1/2, x to the -1/2 minus 1, and then we're going to have 2x minus 3 over 2, x, now -1/2 minus 1, this is minus 3 over 2. And if I asked you to put it in positive exponents, again, we would have to rewrite it as 2x minus 3 over 2, 1 over x to the power of 3 over 2. Now this one. This is not in a form where we can directly take the power rule. If you know chain rule, we could do chain rule, but let's say we can only use the power rule. We would have to expand this by FOIL. So x plus 1 times x plus 1 is equivalent to x squared plus x, so plus 2x plus 1 times 1. And because this function name is y, in terms of notation to take the derivative, we would have to say dy dx and then take the derivative of each term. So bring down the exponent, subtract 1 from the exponent, plus 2, x to the 1 minus 1, so just 2, and then plus 0. So we have 2x plus 2. Okay. Now let's talk about what we do if we have the product of two functions, g of x and h of x, assuming, of course, the derivatives of g and h exist. In this situation, what we do is we'll take the derivative of one term and then multiply it by the other, and then we go plus the derivative of the other term multiplied by the other. So we can say f prime of x is equal to the derivative of the first times the second plus the derivative of the second times the first. Okay, if you want to write g of x first and then h prime of x, that's also fine. Okay, whatever you prefer. Now let's do these examples. So say we have a function, we have a function times a function. So this would be like our g and this would be our h. So what I'm going to do is I'm going to write out my formula first. So when we say the derivative of the first, a way we can write that is I'm going to take the derivative with respect to x of the first function, so d dx of x plus 1 times the second, okay, plus the derivative of the second, which in this case they're the same, times the first. And then d dx is just being applied to this part here in the brackets, okay? If it was being applied to everything, I would have to put another set of brackets around here. Okay, so the derivative of that first one, this is just 1 plus 0, and then times x plus 1, and then again plus 1 times x plus 1. So we're going to have x plus 1 plus x plus 1. So we'll have 2x plus 2, which is the same as this function that we took up here. So we got the same answer. Now let's say we have y is equal to 2x plus 3 times 3x squared. So this is like one function, this is like the other function. Now, because this function is called y, in terms of its derivative name, we're going to call it dy dx. And again, we're going to write out the formula. So the derivative of the first term, so d dx of 2x plus 3 times the second, plus the derivative of the second term, so d dx of 3x squared, times the first. All right, now let's take the derivative. So what are we going to have here? We're going to have 2 plus 0 times 3x squared, plus, this is going to be 3, bring down the exponent, subtract 1, so just x, times 2x plus 3. Okay, so in other words, we're going to have 2 times 3x squared, so this is 6x squared, plus, I'm going to simplify this first, so this is 6x times 2x plus 3. Okay, so now we're going to expand it, so 6x squared plus 12x squared plus 18x. So we're going to get 18x squared plus 18x as our answer. Okay, let's do another one. Let's say that we have the root x plus 3 and then x squared minus 5. So this is like our g, this is like our h. So again, we're going to write out the formula first. So we're going to go d dx of the first term. And when I write the first term, what I'm going to do is I'm going to switch the root to x to the power of 1/2. So it'll be easier for me to do my power rule once I do it. Times h plus the derivative of the second, x squared minus 5x, okay, times the first, x to the 1/2 plus 3. All right, perfect. And now let's actually take our derivative. Okay, so I'm going to erase these here so I have a bit more room. So the derivative, bring down the exponent, and then subtract 1 off the exponent, so 1/2 plus 0. I'll put brackets around this. And then the second one, the second function I didn't take the derivative of is x squared minus 5x, plus the derivative of x squared minus 5, so bring down the exponent, and then we just have 1 left in the exponent. We have 5 times x, which just becomes 5, and then we have x to the 1/2 plus 3. Okay, now let's do some expanding. So I'm going to distribute this term into here and then into here. So I'm going to have 1/2 x. Now I'm going to have minus 1/2 plus 2 in my exponent. And then I'm going to have minus 5 over 2 x to the minus 1/2 plus 1. Okay? And then we're going to have plus 2 x to the 1 plus 1/2. And then we're going to have plus 2 times 3, so 6x, minus 5, x to the 1/2. And now I have to go to the next line, or I can maybe move this over. Minus 15. All right. So minus 1/2 plus 2, so I'm going to have to do a common denominator. Okay, so negative 1 plus 4, so that's going to be 3 over 2. Okay, so 1/2 x 3 over 2 minus 5 over 2, and then I have x negative 1/2 plus 1, so that'll give me positive 1/2 plus 2x. Again, this will be 2 over 2 plus 1 over 2, so this will be 3 over 2. And then I have plus 6x minus 5x to the 1/2, and then minus 15. All right, so now we're going to combine terms here. So we have 1/2 and 2 here. So we're going to have 1/2 plus common denominator. So 4 over 2. So that will be 5 over 2. So 5 over 2, x to the 3 over 2. All right, so that gets rid of these terms. And now I have minus 5 over 2 minus 5. Okay, so minus 5 over 2 minus 10 over 2 for common denominator. So minus 15 over 2. X to the 1/2. Okay, so that gets rid of this term and this term. And then I have plus 6x minus 15. All right. Now we're going to talk about the quotient rule. So in other words, if we have a function divided by a function, assuming the function we're dividing by does not equal to 0, and g prime and h prime exist. So when we have this situation, the quotient rule says that we take the derivative of the top times the bottom minus the derivative of the bottom times the top, and then we divide all of this by whatever the bottom is, and we square it. So let's do a few examples here. And I'm going to write out the equation or the rule first, okay? So f prime of x is going to be the derivative of the top, so d dx of 2x minus 1 times the bottom, minus the derivative of the bottom, so d dx of 4x plus 3 times the top, 2x minus 1. And now all of this is going to be divided by 4x plus 3, and all that is squared. And don't worry about expanding the bottom. We're going to leave it. Usually it's easier to leave it. Okay, so now let's actually take some of these derivatives. So the derivative of the first term is just going to be 2, and then we're going to have 4x plus 3 minus the derivative of that first term was just going to be 4 times 2x minus 1. And then we're going to divide all of this by the bottom, 4x plus 3, all squared. And now let's expand the top. Okay, so we're going to have 8x plus 6 minus, now careful with the minus here, so we're going to have 4 times 2x, so 8x, and then minus 4. Okay, but we have this minus here, so it'll become plus 4. And then again, all this divided by 4x plus 3 all squared. Okay, now for the numerator, our 8x's cancel, and we're left with what? We have 10 on the top divided by the bottom. And again, it's not necessary to expand the bottom. Okay, so it's fine to leave your answer like this. Okay, now let's do this one. So this one we have to be careful because when we take the derivative of the top, we're actually doing the product rule in addition to the quotient rule. So let's first write out our equation and then we'll break it up step by step. Okay, so we're going to do the derivative of the top. So d dx of, now big brackets, because I have 3 minus 4x times 5x plus 1. Okay, so the derivative of the top times the bottom minus the derivative of the bottom, so 7x minus 9, and then times the top. So 3 minus 4x, 5x plus 1. And then all of this is going to be divided by 7x minus 9 all squared. Now, if you wanted to, you could expand the top first, so then it may be a little bit easier to take it, but I want to do this so we can also just practice the product rule. So before we expand this, just because it would be really long, I'm going to just look at the derivative of this part, the product rule part. So remember, the product rule says that we take the derivative of the first, so d dx of 3 minus 4x times the second, plus the derivative of the second, 5x plus 1, d dx of that, times the first, so 3 minus 4x. Now, the derivative of that first term, 3 minus 4x, I'm just going to have the minus 4 times 5x plus 1. And then I'm going to have the derivative of 5x plus 1. That's just going to be 5. 3 minus 4x. So then when I expand this, I'm going to get minus 20x minus 4 plus 15 minus 20x. Okay, so I'm left with minus 40x. And then I have plus 11. So this is going to replace this whole part right here in my numerator. Okay, so now let's plug in what we have into our f prime. So for that very first term, I'm going to have, put brackets here, minus 40x plus 11. So that's the derivative of the top. The bottom is 7x minus 9. Minus the derivative of the bottom would just be 7 times 3 minus 4x times 5x plus 1. And then all this is going to be divided by the bottom squared. So 7x minus 9 all squared. Okay, so now I'm going to expand this here. So I have to distribute the negative 40x, the 7x, and then minus 9. So negative 40 times 7 is negative 280. And then we have x and x, so we have an x squared. And then we're going to have plus, because of the minus and minus, so plus 360x. And then plus 11 times 7, so that's 77x. And then we're going to have minus 99 for the negative 9 times 11. And now I feel like I'm going to run out of some room here. So let me move this over a bit. Now, minus, what I'm going to do is I'm going to leave minus 7. I'm going to put brackets, and I'm going to expand these two terms first. So I have 15x plus 3 minus 20x squared minus 4x. Okay, so in other words, I'm going to cheat, bring this down. So I have what? I have negative 20x squared, and then I have plus 15x minus 4x, so that's plus 11x. And then our constant, we just have a plus 3. Okay. And then, of course, this is all divided by 7x minus 9 all squared. Okay, perfect. Now, let's see what we have here. So we are going to have minus 280x squared. So I'm going to now expand that second part and bring together some of the terms. the second and third term in particular. So that'll be plus 437x minus 99. Okay, so then we're going to have plus 140x squared. And then we're going to have minus 77x and then minus 21. And then again, this is all divided by 7x minus 9. And then we're going to square that term. All right, let's move this down a little bit. Now let's combine all of it. So we're going to have minus 280 plus 140. So this is going to be minus 140x squared. And then we're going to have 437 minus 77. So plus 360x. And then we have minus 99 minus 21. So minus 120. And then all of this is divided by 7x minus 9 squared. Now, if you wanted to factor the top, you could, but it's not really necessary. I haven't asked you to simplify as much as possible, so it's fine just to leave it like this. Okay? So I hope you found that helpful. Thank you very much.